We have Emily Nakashima, who's also from Honeycomb, giving a talk. As I mentioned, we got some great submissions from the Honeycomb team, and she's going to talk about what your JavaScript does when you're not around. Please welcome Emily.
Hello. Great to be here. I think it was very smart of the conference organizers to put the JavaScript talk right after the R talk with a bunch of math, because you know that if there is math, it's going to be hilarious. There probably won't be that much of it, which is true. Anyway, this is what your JavaScript does when you're not around. My name is Emily Nakashima. I am a front-end or web or product engineer at Honeycomb. If you haven't heard of Honeycomb, I like to describe it as a power tool for understanding what your software does in production. So you send us events, we store them, and we let you query and calculate by any field, break down on high cardinality values like user ID, and see the raw data behind every result. Before Honeycomb, I worked at a handful of companies in San Francisco in various parts of the stack, managed teams, and even been on the pager rotation a few times. But my jam is really browser JavaScript, browser monitoring, especially the kind of work that fits into the bucket that some companies are calling front-end infrastructure now. And I want to tell you about a funny thing that I have watched happen over the course of the past maybe 3 to 5 years. At the kind of exact moment that most of my back-end developer friends were figuring out how to get really solid visibility into what their apps were doing in production, of course, all of my front-end developer friends were very busy moving a lot of that application logic off of the server and into JavaScript in the client. Single-page app frameworks, especially React at this moment, are helping developers build the newest generation of really app-like browser UIs. And the architectures that these frameworks make popular can really chip away at the expectations that we have for how user interactions typically relate to server requests. And I think even if you're not using these frameworks or technologies specifically, there's a very high likelihood that your company is writing and deploying its most complicated JavaScript ever right now at this moment. And at the same time, of course, this code is usually running in kind of one of the least monitored and least visible parts of the application stack when it's out in production, which is our customers' browsers. So, we're monitoring people. We know how this story ends. As we move more application logic to the browser, we kind of invent more and more ways that we can leave our users staring at a blank or broken page when something goes wrong. And yet, whenever I talk to people about their alerts and monitoring, over and over, I hear the same thing, which is that so many of us are on teams where we're more likely to be paged for a server issue that affects no one than for a browser issue that affects everyone. And I think that rather than wait for our eventual Wile E. Coyote-style demise, we need to make sure that we can proactively identify and fix issues in the browser just like we can on our servers. So I want to talk about how to solve this. I want to talk about the fastest route from no visibility in the browser to having a rich view of how your users experience your app. Actually, this is a great question. How many people in here regularly write browser JavaScript? Yes, not many of you. That's great. That's totally perfect. If you are not a front-end engineer or JavaScript engineer or even doing product engineering, that's totally fine. I want to talk to the people who understand production and understand how to make sense of production data. And I want to give you some ideas to take back with you to talk to people on your teams who do write browser JavaScript, because I think many of us in one way or another are now supporting JavaScript apps, whether we work directly with that JavaScript or not. So here's what I'm going to cover. First, I'm going to talk a little bit about how we instrument Honeycomb, the app. Then I'm going to talk about how to make sense of all the weird data that you get back in the client after you instrument. And finally, I'm going to talk about how having better observability in the browser can change the way your teams write and think about shipping code. So the web app portion of Honeycomb is built with React, SCSS, and server-rendered Go templates, and a whole lot of data shoved into the client. We are not a single-page app, but we have some kind of complex single-page app-like behavior. For example, all of the interactions in that query builder are done via AJAX, and we have these relatively complex UI components like the history sidebar and all these graphs. So things can go wrong in the client in a lot of ways that won't manifest in our server logs or in our server-side metrics. So how do we know that this complicated thing is working? Our basic front-end monitoring toolkit doesn't actually have very many moving parts. We could set it all up again from scratch in a couple days if we needed to. There's kind of these two pieces that are the big pieces, which are performance monitoring and error monitoring. And I would say the error monitoring side of it probably took a couple of hours to set up. This was before me, but it's pretty simple. And then the performance metrics we collect, I instrumented in less than a day. So it's not a huge investment to start getting this kind of visibility. So we measure performance. Since we're not a single-page app, the timings that we focus on now are primarily loading times. There are lots of other things that we could start tracking that we're not quite yet. And I won't cover performance metrics in too much detail, because I think there's a lot of really great content out there from other conferences like Velocity, Fluent. The one thing I will say is that the Rail model from the Chrome DevRel team is the most helpful thing I've seen if you kind of want a comprehensive take on what kinds of performance metrics you should be tracking. If you haven't heard of Rail, it focuses on these 4 different types of performance measurement. So measuring response, animation, idle, and load. And Google has these kind of ambitious suggested targets for each one. Response is about input latency. So for example, if someone clicks a button to submit a form, they should see the screen change in response within 100 milliseconds, even if it's just to show a spinner or tell you that the web app is kind of working on whatever input you just gave it. Animation is the one that kind of makes the most intuitive sense. If your app has animations, they should run at 60 frames per second, which gives you about just over 10 milliseconds to do the calculation for each frame. Idle is all about making sure that the main thread is available when you need it. So for example, if you do a lot of work and set timeouts so that that work can be non-blocking, the units of work should be small enough that if the user clicks on something in the middle of one, there's no perceptible wait as the browser finishes that task and comes back to whatever user input on the main thread it needs to be dealt with. This one, idle, can be a little bit difficult to instrument as a run metric, but you can use dev tools to test it out locally. The other two you can instrument and beacon that data back just like you would loading data. And of course, loading is the one of us that I think many of us do track now. Google suggests that navigating to a new page, whether it's via push date or via hard browser navigation, should load and start rendering content within 1 to 2 seconds, which is pretty fast. Honeycomb's instrumentation focuses on loading performance at the moment, but I think as we add more and more app-like behavior and more complex interactions, we'll likely shift to trying to capture more data from those first 2 categories. So that's the performance side, and of course we also monitor JavaScript errors. And there are a lot of really great vendor products in this space right now. They all work roughly the same way. So they have a little bit of JavaScript that customers deploy with their app. Usually they'll bundle it in with the rest of their front-end code. That JavaScript is going to sit in the browser, listen for uncaught exceptions, and when one happens, it's going to beacon the event that represents that exception along with its stack trace and any metadata back to the vendor server. From there, it's displayed in the dashboard and hopefully used to generate alerts. As far as specific tools, we use Honeycomb for most things internally, but really everything I'm going to talk about you could do by combining other tools together. If you are selecting new tools right now, I think the features you need are the ability to draw time series. For browser data in particular, it's especially useful to have good support for percentile calculations, median, P95, P99, because you'll get weird numbers on either end that you probably will want to just ignore. And you kind of want the ability to explore high cardinality data. So for example, be able to graph loading performance by browser version or by team ID. Honeycomb lets you do high cardinality stuff on the fly, but more and more time series databases like Influx are moving toward allowing you to store millions of time series. So if you think ahead, you can kind of do these graphs, hopefully in the tools that you're using now. For performance metrics, it's also worth mentioning that a decent option that most people don't know about is Google Analytics. It actually collects navigation timing data by default, page load data, and you can send user timings to it too. So it's not great for being able to generate granular alerts, but it's not a bad starting point if you currently have no performance metrics at all. And for errors, we use Sentry, which is great. I think the best product in this space is Bugsnag, since I think it has the best grouping and visualization, but I'm very biased because I used to work there, so take that with a grain of salt. Like I said, lots of options. And the things I'll talk about you could really do with most of the tools in this space, or you could roll your own. It'll just take more or less work depending on what you pick. But really, like, don't roll your own. These are like $100 a month. There's also no need to write your own instrumentation code if you're just getting started. We write our own instrumentation for performance metrics, but that is because I have been doing this for a long time and have too many opinions. If you are just getting started, you should use the Boomerang library by Philip Tellis and Sosta and a bunch of other contributors. There are a bunch of plugins for Boomerang that will capture page load timing data and dozens of other characteristics about the in-browser experience and beacon it to wherever you choose. And of course, the error monitoring products also all come with their own instrumentation libraries. These are usually open source, so if you want to see what it's doing, you can look in there. And these can typically be installed in a couple of lines. So easy going on that end. So up to this point, everything I've talked about, monitoring performance and errors, probably sounds exactly like some of the things you already do on the server side. We want to understand regressions. That's really familiar. But I think there's a few things that are a little bit different. We want to deeply understand how the product is used when we're monitoring the front end. It can be really hard to tell if something is broken if we can't put numbers around what normal usage looks like. And if this sounds a little bit like product analytics, that's actually exactly what I'm talking about. I think that product analytics shouldn't just be for product managers and marketers. I think they're really useful for engineers to understand whether their apps are working or not, whether something has changed from what you think of as normal. I think in the browser, there's also this third category that we really don't have to deal with at all on the server side that really gets overlooked. And that is that we want to understand the environment that our code is running in. We obviously can't say, OK, I want my code to run in a T2 large with Linux and the following binaries. We run on whatever is there when we're writing code for the browser. And it can be really helpful to collect data about exactly what that is, browser, operating system, screen size, API support, so that we know what resources we have to work with. To kind of take that and flip it 90 degrees, I like to sum up what you should be able to understand as the ghost of code past, which is, did we break some old feature we shipped? The ghost of code present, which is, did we somehow subtly change our customers' usage patterns when we ship this new feature? Was it in a good way or a bad way? And then finally, the one that everyone forgets, which is the ghost of code future. This is my favorite. We can try to understand things like, do a large enough percentage of our customers use a browser that supports HTTP2 such that it might be worth upgrading our servers to support it? Or do most of our customers use the site on a tiny laptop or plugged into a big monitor? We could look at the measurements for the screen dimensions and decide if it's the latter and everyone has all this extra screen real estate, maybe we should redesign the page so that the graphs can render larger and maybe have a higher granularity so that we can make better use of that space for people who want to. And of course, it's important to remember that we want to instrument these things now so that that data is there when we want to answer these questions, rather than realizing we have these questions and then trying to scramble to instrument it after the fact. And I think if you can, it's really valuable to try and put data that answers all three of those questions into the same tool. So we try to do this with Honeycomb. This is a screenshot of the graphs I look at most often for Honeycomb for browser stuff, and they're definitely made from having performance, usage, and device data kind of commingled together in the same data set. And I think that's useful because it's really common for investigations to actually jump between these categories from one to the next seamlessly. Maybe you're looking at a regression and you're trying to figure out, like, why did usage of this page drop off? OK, so there's a spike in errors. It looks like we broke this feature in this browser. Why is it broken? Well, look, there's our deploy. And then we know that in that deploy, we upgraded a library, and it uses some API that some browsers don't support. OK, so browsers don't support it. What percentage of our customers are on a browser that is likely to support this API in its next release? Can we switch to using this soon? So on, that kind of thing. In fact, if you look at the event data that we're sending back to our instrumentation that creates these graphs, it actually has all three types of information commingled together at the level of the individual measurement. So this is an example of the kind of event that we send on page load to track that initial page load event. And it's packaging up information about usage, which is that is encapsulated in the event type, which is that the user navigated to a specific page. And then we also include A/B test groups, so that's kind of about usage too. We know which features they're using. For performance, we have the actual page load time, and then The metadata that we want with that is the asset version, so we want to understand which set of deployed assets this person is using. And it's actually really important to send that with your JavaScript and not assume that whatever is running on the server is what's running on the client. I have noticed that many people, if it's a site like Honeycomb that has graphs, will leave the browser window open for months at a time. So you want to know when you get a bug report that's a bug that you think you fixed a week ago, whether it's a true regression or someone is just running a really old version of your front-end code. And then at the very bottom, you'll see that we have a ton of metadata about capabilities. So we have the user agent, which will help us figure out the browser, the device, the version. And then we also have information about the size of the window, the size of the screen. And one thing we're also doing, which I don't have a good code example for, is we're querying the browser itself to check for support for browser APIs that we might want to use in the future. So pushing as much metadata as you can will help you when it comes to the next section, which is trying to make sense of all the weird data that you get back from the browser. Everything I talked about in that last section probably sounds super simple in theory, but sometimes the data we get back is much weirder than we would expect it to be. Every once in a while, you do get some stuff that comes to you that makes complete sense. Here's a really good example. We deployed a small behavior change to a graph on the site, and then we start seeing this. It's a JavaScript error. The error is reference error. The message is, this draw graph is undefined. The stack trace points back to one of our own JavaScript components. And this is the kind of error I love. It's super easy to dig into. There's a function with a unique name. We can just follow the stack trace to figure out what's going wrong. In this case, we just moved a function from one scope to another and forgot to change the invocation. And so it's very easy for us to just go update that reference and fix it. This is the kind of thing we love to see. It's easy to understand. It points back to our mistake. But everywhere that I've worked, these kinds of things only make up about 20 to 40% of the new client-side events we see. The rest are usually much harder to make sense of. So this is much more typical. The exception class is NS error XPC security manager veto. This is not a common error class I've seen in the browser before. The stack trace doesn't look like it's coming from one of our files. It's coming from someplace called top level. I have never been to top level before. It's happening dozens of times, but it seems to only happen to one user over and over again. So how do we solve this? That's right, Google. We Google the confusing string. I look and I find a bunch of forums where people are saying, I'm trying to write this Firefox extension. It doesn't work. It keeps throwing this same error in a loop over and over. Great. Now I have a good guess. Our code is fine. Someone just installed a bad browser extension. And it's totally broken. And it's throwing this error every time the user comes to our site. I should say the good vendor tools out there, Sentry, Bugsnag, most of those are set up to filter out errors from extensions by default. But if you are rolling your own error monitoring or using a tool that doesn't have support for this, you will want to handle this case. At GitHub, we used to roll our own, and we had to add code at the point of collection to filter out browser extension errors by looking at the stack trace. And I would say before we started making that change, probably more than half of the browser JavaScript errors we would see on a given day would be from extensions. And it's really important to start filtering those out because that's someone else's code. There's no way we can fix it. It's not actionable, and it's just noise that prevents us from trusting our data. So the good the good error monitoring products will filter these out by default, and then anything else that falls into this category where you chase down what it is and it's not useful, the good products will have a button that's just ignore. Make heavy use of that button so that you can help keep the data that's actually in your dashboard really actionable. So number one, what is my JavaScript doing when I'm not around? It is hanging out in a noisy room. We use Webpack to package up all of our JavaScript and CSS into 2 files, and it's very easy for us to start to believe that that's the total of what's running in the browser at a given time, but our monitoring is constantly telling us that that isn't true. For one more example, there's this JavaScript error we suddenly saw spiking out of nowhere one day. The exception class is just error, always a favorite, very informative. The message is, cannot find module bind all, and it's coming from a third-party CDN. So this is an analytics vendor that we work with. They have pushed bad code to production, and they are experiencing what is effectively an outage. Their infrastructure is fine, but they've deployed code that is throwing an error on the client, and they're no longer collecting data. So the kind of cool thing about this is we actually found this out a few minutes before it went up on their status page, because we get a Slack notification whenever a new error happens on our site. That was great because if we had somehow been depending on this code to run, we could have taken action right away and redeployed without this script. We didn't need to, but it was a good wake-up call for us to get rid of some callbacks that we had that assumed certain third-party code would always be there and would always run. And this seems like it might be one of those rare kind of like one-time problems, but once you start looking at it, you'll realize that you see third-party code issues like this constantly. It's hard to overestimate the magnitude of this third-party code problem on some sites. Advertising and remarketing tags, you install them on your site, typically with one line, but they very often will load other scripts, and sometimes they will load different scripts for different users, so it's hard to know exactly what they'll load. So this graphic is data from Ghostery. They have an enterprise product that will give you visibility into this kind of stuff if you're curious. And this is their report from the site tmz.com. And this is all the third-party code and tags that can load on that one site. So if you look at the nodes out to the far right, those are tags that have been loaded by tags that have been loaded by other tags. And if you total this all up, they can load 539 possible tags from a total of 68 different unique vendors, all of whom have access to your client-side data. But that's a rant that I'll save for a separate talk. If you allow these third parties on your site, all of this code is going to run in the browser with your code, and it's usually sharing the same global scope, so there's a lot of space for things to go wrong. I think TMZ is a little bit of a pathological case, but the average e-commerce or media site often won't look too different than this. So for me, working with this kind of third-party stuff, the thing that's been most helpful is using Webpack for our JavaScript builds, because that will automatically move more of our code out of the global scope into anonymous functions, and it makes us be much more explicit when we are referencing external globals, which means that when third parties do weird stuff like throw errors or inject their own versions of dependencies, that is a favorite. There's a third-party tag out there that injects its own version of jQuery into the page, which is amazing. But Webpack has really helped us be a little more sheltered from the fallout. And of course, on the flip side of that, our users are developers. I've worked for a couple of DevTools companies, so a huge number of our customers are developers. And so many, many developers use ad blockers all the time. No surprise. I think the important thing to keep in mind with ad blockers is that they often block things that you wouldn't think of specifically as ad scripts. So pretty much any third party, including your analytics provider, and any browser monitoring that uses a vendor domain could be blocked. The best part is that this often includes error monitoring products, which is really fun. So if you're trying to figure out if a third party is causing an error, you're not going to find it in your error monitoring. If you are super concerned about this problem, you can proxy your browser monitoring data through your own domain, since you know that that won't be blocked. But I think most of us just sort of suffer with it and try to remember that some percentage of things are getting lost in the ether. Number two, our code doesn't always run where we think it runs. It has a tendency to wander off to one place or another. This is one of the weirdest lessons for me. We deploy our code to ui.honeycomb.io, which points to some Amazon servers in the cloud. We think of our code as always running at honeycomb.io when it's in production, but sometimes we see other domains pop up in our monitoring. One thing that is much more common, weirdly more common than I thought it would have been, if you have a site with really interesting graphs and visuals, it's reasonably common for people to copy-paste all of your front-end code with the JavaScript intact into either a knockoff site or some totally unrelated product and start running it, which is weird. And it's especially weird when they leave in all the code that beacons metrics and errors back to your servers. The slightly more common case you might see is proxy sites. One of the most common proxy sites out there is Google Translate. Google can serve your code on the translate.google.com domain. So this is our marketing site translated into Portuguese. This is cool. This is a legitimate use case. We want foreign language customers to be able to check out our product and maybe sign up for a trial, so that's really helpful. There's another case that's kind of like this that you might want to consider, which is there are proxy sites out there that help people get around firewalls. So there are projects like GreatFire that help internet users in countries with internet censorship get around restrictions by showing a mirror of a blocked political or news site. And depending on what kind of information you host, it might be important to you to make sure that your site works in cases like this. If you want to support these, you don't have to do too much to handle these cases, since the proxy is usually handling and rewriting all the headers and URLs and that kind of thing. The one big reminder for me was, don't write JavaScript where you check a host name and assume that that means production. You should put a meta tag into the page or something else that prints out the actual environment and check that instead. On the flip side, if you feel more meh about proxy sites, you can turn your monitoring into a tool to detect them. So you can write code that sends an event if it detects a different host name and reports them back to your monitoring. And then, as I've had to do in the past, you can contact the sketchy knockoff of your site and send them an email asking them to stop. That's always fun. And number 3, network problems are happening all the time. Sometimes our JavaScript just doesn't get there. We know from our stats that we have plenty of customers who are on airplane Wi-Fi or on 3G or in Australia, and they are having quite a different experience than we are in the office. This is particularly important now that we're using a JavaScript framework like React. With some single-page app frameworks, it's very easy to create complex request dependencies by mistake. So if you look at our UI here, all of the gold boxes show UI components that have the ability to trigger a network request. And of course, in React, it's very common to nest components, so if we're not careful, it's easy to inadvertently trigger sequential requests as you embed components inside components. And if you have a slow connection, those cases become incredibly frustrating. For us, we run on AWS, so we're not going to do much engineering at the network level to try and make requests faster, but we do want good visibility into when and how often network problems are happening. So here's an example of an error we might see. This is reference error, app is not defined. Seems to happen sporadically to many users. And when you look at how we're loading this code, it's suddenly very easy to understand what's happening here. There's this bootstrapper file that loads first synchronously, and then that second script, when it shows up in the stack trace, throwing that error, we can just look at it and tell that the network request for that first file just timed out or failed in some other way. On sites where I'm diligent about cleaning up new JavaScript errors, I'll find that these kinds of failures are maybe 10 to 20% of our overall error volume. So one of the most common cases we're dealing with. So it's worth trying to give these kinds of errors a custom error name, like warning script failed to load, so that they're really easy to identify when you see them pop up, so that everyone on your team can be saved that 5 minutes of investigating to try and figure out what that means. They happen all the time. Obviously, there's not a whole lot we can do if an entire asset file just fails to show up. We may eventually look into using Service Worker in the browser so that we can have offline support and have fine-tuned cache control and refresh stale things in the background. But for a small team like us, for now, we just want to try and be smarter about when we make data requests and try to move them earlier in page load. So one behavior change for me that's really helped is to start using a network simulation tool to look at failure states and slow request states. It's worth kind of testing out your site with like a 3G connection or a DSL connection, and also look at offline states to see if you have these like daisy chain request issues, and to kind of get more familiar with what kinds of error messages you'll see in your monitoring if something fails to load. You can use tools like Charles Proxy to do this, but some browser dev tools now also have this built in, which is really great. So this is Chrome, and it's basically two clicks from DevTools to be able to toggle on 3G mode and start surfing around your site to see how it feels. And finally, we find that our app is not always used the way we like to think it's used. This is a favorite error from when I was at Bugsnag that I will treasure forever. The exception class for this error is waking up dev. And the imp emoji is definitely not a custom error message that we have in our code base. So what's happening here? Developers. Developers tend to run a lot of code from the browser DevTools console. So this one is just some developer throwing an error in the browser DevTools console to troll us because they know that we're an error monitoring product. We're going to see this. But sometimes we can actually get useful information out of seeing what developers are console hacking. So for example, one time I saw someone trying to traverse the DOM to get to text that was in a DOM node. We had API keys in our UI, but we had accidentally disabled text selection via CSS. And so watching some of the errors that were coming out of the console, I could tell that this person was trying to traverse to that node to be able to copy paste it more easily, which is like sad, like the links that people will go to not have to email us. But that was a really helpful error to see because it helped us spot the CSS bug that we needed to fix. If you have lots of developers as customers, you will start to get to know this telltale browser DevTools stack trace really well. In Chrome, look for file anonymous, and then injected script in the call stack. Firefox and Edge have slightly different traces, but it'll start to become really familiar. I think in particular, you can learn a lot from watching developers try to hack you. This is a small subset of our users on teams that include a script tag in the name. And the nice part is that these users tend to throw exceptions as they're kind of poking around the site. So it's kind of fun to keep an eye on the errors coming out of their accounts and make sure that we are thinking about security for the same cases that they're thinking about. So that was a lot to try and make sense of. Thinking about all that, is there anything that we want to do differently now that we've seen all this? We have our browser monitoring toolkit. We have something for performance, something for errors. I think part of the power of having these two tools together is that they tend to deal in two different primitives, metrics and events. And I've started shifting more from thinking about those two tools as a performance tool and an errors tool, and thinking about them more specifically as a metrics tool and an events tool. Anything that we want to see as a time series or a count or gauge, we push to the metrics tool, whether it's performance data or not. Anything where we want to preserve the raw data, we can send to our error monitoring tool or an events tool as an event, whether or not it's actually an error. In practice, we usually end up sending both of these types of data to Honeycomb since it kind of handles both cases. But if you have something that does time series and something that does events in your toolkit already, that's great. You're good to go. I'm not advocating changing tools, but I will advocate for changing when you send the events. I think kind of on this journey, I've found plenty of things that are not strictly errors, but that are still things that we know we very much want to capture. So like I mentioned before, we send our product analytics as events too, so that when people use an interesting feature on the site, we'll always send an event when that happens. If you use an error monitoring tool like Bugsnag or Sentry, you can actually configure the level on your errors, just like you would set a log level. So you can log custom non-error events and set the level to warning or info, as opposed to assuming everything is an error. There's a really good use case for that. A common problem that people have with single-page apps is that they don't trust the data that the app is currently displaying. Like they've kind of been clicking around through a complex navigation path, and all of a sudden they feel like the UI looks weird, or they click a button and nothing happens. And I think we all have enough experience using other people's single-page apps that we know to like refresh the page to try and fix it. So we kind of wanted to understand the circumstances where people didn't trust our app and chose to refresh. We basically send an event whenever someone presses Command R, Control R in the browser on our site. And then we log that as an event with level info, not error. And then we can look at the pages that users refresh the most and get a sense for when users don't trust our app. We can even get an alert sent to Slack if they exceed a certain threshold, which might be a sign of a regression if someone keeps trying to refresh a page, like something might actually legitimately be broken. Not surprisingly, the pages that I have seen that users tend to refresh the most are usually pages with complex graphs or visualizations. Sometimes users get impatient waiting for data, or they don't believe the graph, they'll try and refresh to fix it. But one page that's been surprisingly common to see refresh across different apps is the team invites page, which I think comes from this case where people are onboarding a teammate and they like want to see if their teammate gets in and can start using the app. So this was a useful cue to me that we should definitely show the invite state on that page and maybe think about having it live update when that user signs in and their state changes to accepted. Another related and super interesting thing I've tracked in the past is rage click tracking. You know, when users get frustrated, they start just randomly double-clicking and triple-clicking on elements in the UI to see if they'll do something. This is a technique that I heard about from Philip Tellis and Nick Jansma of SOSTA at last year's Velocity. And they set it up so that whenever someone clicks in the SOSTA UI more than a couple times in rapid succession, it'll record an event. And then when you look at those events, you can see the page they're reviewing, if there are any errors, the list of events that happened before the rage click sequence, and they can try to figure out what was so frustrating. I think this is a super interesting data point if you're still working out your UI design patterns or if you're worried that a part of your UI is confusing and hard to use. I think a common case that I found where this seems to happen is when UI elements load data async, but they don't show a spinner. So people click them, they expect something to happen, and then it doesn't do anything, and then they just keep clicking to see if that'll make it happen. So this kind of tracking really helps you find and fix those cases. We've noticed that as we start looking at our data more and using it more, we keep making our events wider and wider as we go. So if you remember that sample event I showed, it had some different browser stats in it, but don't forget, anything that you can check with JavaScript, you can collect data about and add to an event. So you could be checking installed fonts, screen dimension, color depth, browser language, online or offline status, emoji support, other native API support, page visibility, like knowing whether or not the tab is backgrounded, connection type, whether they're on like Wi-Fi or 3G, support for emerging browser APIs, so just knowing, you know, are our users' browsers overall new enough that we can use this new feature. You can collect IP address and use a GeoIP library to try and map your users to geolocation. And of course, you should also be augmenting events with information about your app that will help you understand what's going on. So a great thing to put in there is A/B test groups. You should do JavaScript asset version, CSS asset version. Sometimes it's nice to know whether something was part of a canary deploy or not, so that if there's a little blip and spike, you can immediately see, oh, that was because someone rolled something out and rolled it back, rather than some other thing changed to fix it. User ID, username, team name are really helpful. Plan type can be useful. Like, does this only happen to big customers that are on an enterprise plan, or does it happen to everyone uniformly? I think the wider the event, the easier it is to dig into your data after the fact and figure out what actually happened. At Honeycomb, we talk a lot about observability, the ability to see and understand and ask questions about what your application is actually doing in production. And having this kind of rich landscape of metadata to slice and dice with is a huge part of how you get there. So that was a lot of browser monitoring all at once. What does it all mean? For one, if you had any remaining doubts in your mind, I think browser monitoring is ready now. The libraries and vendor products that are available are super easy to get started with. They're quite mature. And I think if you have the ability to deploy JavaScript to the web, you are ready to use this stuff. And I think monitoring performance is not enough, especially if you're using a framework like React or Ember or Angular to build appy functionality into your site. I think you really need to be instrumenting and understanding performance, exceptions, usage, and device capabilities. I think the corollary to having all this monitoring is that front-end developers really can get paged now. That doesn't necessarily mean that you want to have their own PagerDuty rotation for them, but I think there's definitely channels where, as a front-end developer, I want to be pushed alerts about what my code is doing if it's doing something unexpected. Chat is my favorite place to get these. We can push sentry errors to Honeycomb and sentry errors and Honeycomb triggers to Slack, to the front-end chat room, and then the whole team can see it. But I think getting alerts anywhere is better than getting them nowhere. I think front-end developers should get alerts in at least two cases. One is when there's a spike in browser JavaScript errors happening to many different users at once. So sometimes you get false positives because one person has some, they have like a nightly build of a new browser or something like that. You really know that there's an issue when it starts happening to more than one person. So that's the pattern to look for. And then we also want to get alerts when front-end latency is going up, but back-end timings aren't. I think if your company is sort of DevOpsy, they will be really, really excited about this. There's something that feels really nice and really fair about having your whole team work with alerts and be on the hook to respond to production issues. It does wonders for helping your team develop empathy for folks on your pager rotation and helps them better understand how to write production-ready software. I also think that the dream of testing everything everywhere is well and truly dead. Many browsers now roll out a new version every few months, and they're getting better and better at building them to match the specs. I think there are just too many browser versions out there for our small team to either look at each one or try to write tests that run on each one. On the flip side, this means that I can finally give up my dream of fixing those crappy Selenium tests that are always read in 2 or 3 browsers, which feels really good. But the hard part of this is that with single-page apps, data is typically carried from one page view to the next. So if you think of your browser data, or the data you have in your browser app as a state machine, you can get much more complexity than you could when it reset every time you refresh the page. You won't be able to test every state. We still do unit tests, and we do just snapshot tests, which are great. And we want multi-browser tests for any kind of major libraries that we're sharing with other people, but we don't need them for everything. So these tests can go back to being just one tool in our tool belt instead of the one thing standing between us and our customers dealing with a broken experience. The monitoring team doesn't know what the JavaScript does. There's usually a team that is responsible for the monitoring, and that team is usually very far away from the JavaScript development team. That team may still assume that a state where users are seeing broken stuff is going to correspond to a spike in 500 errors. It is worth trying to bring these two teams together and talk about what JavaScript failure cases look like and talk about if both teams think that you're monitoring the right things. I think the best tool is the one your team will use. We have lots of things that we could track with a time series database or with a web analytics tool or with some sort of other error monitoring tool that we choose to send to Honeycomb instead. It's more important for the data to be someplace that developers on our team will see all the time than it is to be in the perfect tool for that kind of data. I've had a lot of success moving product analytics into error monitoring tools if the team uses those all the time, because that's a place where devs are looking already. An analytics tool could be really nice for slicing and dicing this data to compare to business metrics, but those products often don't have alerting built in, and I've never been on a team where engineers regularly look at the product analytics. So we need a better way to get notified that something important is happening with that data, and putting it in a place where our tools already work is how that happens. I think this is all particularly relevant now that the pendulum is kind of swinging back from the native app side a little bit. People are talking about progressive web apps, and even with longer release cycles, I think mobile app developers have been much better than front-end developers at using monitoring to find and fix errors quickly. So if we really want people to take browser applications seriously as an alternative to native applications, we need to reach that same level of reliability. I think better monitoring is a huge part of how we'll do that. All right, that's all I got. Thank you. Probably have 7 seconds for questions. Okay.
You have 5 minutes.
Awesome, thanks. All right, well, if you think of a question later, come find me out there. I love to talk about this stuff.
All right, so now we have the long afternoon break, so get more caffeinated. We will resume at 3:30, so in 35 minutes. Thanks.
Thanks again.